Good morning, everyone. It's great to be here. I'm going to be talking about putting the dev in DevOps, which is something that I care a lot about because I do DevOps and care about DevOps. But a lot of the DevOps talks that I've seen so far have been about bringing operational thinking to developers, giving them pagers, putting them on call, letting them be in charge of their own deployments, and that kind of thing. But I haven't seen a lot of people talking about kind of switching that around and bringing development practices to operations. As was said, I'm Katherine Daniels. You might know me from the Twitters as BeerOps. I'm a senior operations engineer at Etsy, and I am co-author of Effective DevOps from O'Reilly, going to be published hopefully the end of May, getting close. My co-author is Jennifer Davis of Chef. She is a dev, and I am an ops, so we are doing some nice ops deving with the book there. So Etsy, for those of you who don't know, is an online global marketplace for handmade and vintage goods. This is a picture of our headquarters in Brooklyn. We've got offices in 7 countries around the world. And we've got things like Coda's Craft and blameless postmortems. And I like to kind of think of it as a culture that is doing DevOps without calling it DevOps. Some numbers, just so you get a sense of kind of the scale that we're operating at. As of December 31st, 2015, we had 24 million active buyers around the world, 1.6 million active sellers, and 2.39 billion in GMS, which is gross merchandise sales, or the total dollar value of goods bought and sold on Etsy. Lots of yarn and handmade cozies for your tea mugs or whatever. So today, I'm going to be talking about this operational project that I've been bringing some development to. This is our infrastructure provisioning project, so I'll go into that and talk about kind of some of the problems that we ran into when trying to work on this project over the past few years. I'm going to talk about what we did to add some dev to it, and what the results were from that, and then hopefully some takeaways that will be useful to other people, regardless of the particulars of your projects. So infrastructure provisioning for us is a project that we refer to as Project Indigo for reasons that I will get into in a little bit. Infrastructure provisioning is it's our process of taking servers in our data centers and transforming them from being kind of these really expensive rack-mounted paperweights into useful servers that do things like serve our web traffic or our databases or our API. Data centers are pretty cool. We've got 3 of them. This is not one of ours, but you get the general idea. Lots of pretty cables and hardware and fancy blinking lights. We've got 2 on the East Coast and 1 on the West Coast of the United States. And even with an awesome dedicated data center team like we have, the data centers are still a lot of work to set up. There's a reason that the cloud is so popular these days, because it takes all the work that you have to do to maintain a data center, and it takes that away and makes it somebody else's problem. So infrastructure provisioning, the things that we were doing by hand for several years. Inventory management, we need to know where servers are in the data center, what racks they're in, where in the racks they are. Disk partitioning, some hardware RAID or software RAID, or sometimes no RAID. We configure the IPMI interface, which is an out-of-band management interface that allows us to do cool things like essentially hit the power button on the server without having to be in the data center and physically hitting the power button on the server. We do some initial network setup to get servers online in the first place. When they're ready to actually be provisioned, we obviously need to install an operating system. That's a pretty important piece. We do DNS, so we have nice host names for servers. And then final networking setup, what this means for us is we have different subnets for different groups of servers. So the Hadoop cluster, for example, has its own subnet. So when it starts doing backups and just spewing data, it doesn't take down the rest of our network. And finally, we have configuration management. So we use Chef. We want to make sure that we don't have any beautiful, unique Snowflake servers. They're all managed with Chef. And so up until 3 or 4 years ago, all of these steps had to be done by hand. And when you're operating at the scale of a few hundred or a few thousand servers like we have, that's a lot of work. So back in 2012, summer of 2012, Tumblr at Velocity Santa Clara gave a presentation called Scalable System Operations, where they talked about the solution that they had to this infrastructure provisioning problem. They wrote a tool called Collins, named after Phil Collins, as you can see from the slides here, that kind of took all these individual pieces, their similar checklist, and it just glued them all together with this tool that they wrote. The Etsy ops team saw that, and they were like, that is a really cool idea. At the time, Collins wasn't ready to be open sourced, and even if it had been, it wouldn't have been a kind of drop-in-the-box replacement or solution for us because, for example, they used Puppet instead of Chef. But they got really inspired by this idea, and at the conference that very day, got some scotch, got some whiteboards, took out their laptops, and started writing their own version of this. And that was pretty much all of the planning that went into this, because this was the ops team, and they didn't think of themselves as software developers. They had thought of themselves as just a bunch of ops people, and they were just writing ops scripts. So nobody thought of this as a software development project. The planning that went into it was, again, these requirements. And then people thought, a couple years down the line, as this set of tools was developed more and more, that it would be nice to have it also be self-service so that other teams aren't as dependent on the ops team to get servers provisioned. That they can, we thought it would be nice if they had like a web interface that they could go to and be like, I need some web servers or some API servers. And we also thought it would be nice to have bulk build capabilities. So what that means is instead of having to run this tool 42 times for one rack of servers, you could just select all and say provision all of the servers as web servers or whatever. But that was really all of the planning that went into this project. So because Tumblr named theirs after Phil Collins, we decided to name ours after Peter Gabriel, and it became known as Project Indigo. So I'm going to go through the various tools in Project Indigo real quick, kind of so you have an idea of what we are dealing with here. So we started out with a tool called Gabriel. This was the first one we wrote, and this was a command line tool that did things like install the operating system, do the final networking setup, generally take a box and get it ready to go into production. Then we wrote Czar, which was a command line tool that engineers would run to decommission boxes, to essentially undo everything that we had done with Gabriel. Sledgehammer was a command line tool for doing essentially disk partitioning. It does some other asset management, inventory management sort of stuff. And this morphed into what we call Unattended Sledgehammer. This is not a command line tool. This is something that will automatically get booted to if a machine does not have an operating system already installed. This allows our data center team to press the power button on a box once it's all plugged in and everything, and it sets itself up in inventory management. It does its initial network configuration, and it sets up its out-of-band management interface. So this was written in the course of approximately a day last year when we were doing a big data center move, because we realized that it was going to take hours, days, weeks for the data center team to do that all by hand on every single box that we were moving. So Unattended Sledgehammer has two parts to it. It has what we call the executor, which is this bootable disk image that if a box does not have something else to boot to, like an operating system that's already installed, it will network boot to this image. And this image does a little bit of setup, but mostly what it's responsible for is installing and running what we call the Sledgehammer payload, which is what actually does all of the unattended Sledgehammer tasks. We also have an API that we call the Indigo API. This does a few things, but mostly what it allows us to do is have a locking mechanism so that if we do something like power on an entire rack of servers, or an entire row of servers even, they won't all get provisioned with the same IP address, because that would be bad. And we have a little tool called the Indigo sweeper, which actually is the one thing that we have that's not a song reference to a Peter Gabriel song. And what it does is it essentially keeps us from DDoSing our own cobbler servers when we do these multiple builds at once. And of course, there's some shared library code that is used by all of the above. So that's a lot of stuff there that I just threw at you. Basically, the short of it is that we have kind of two sets of tools and two different use cases for them. So there's the command line tools, Gabriel, Sledgehammer, and Czar, and these are used by engineers in the office to take boxes from being mostly provisioned to all the way provisioned. And then we have Unattended Sledgehammer, which is used by the data center team to take boxes from brand new, fresh out of their packaging into being mostly provisioned. And again, these are very different use cases, and they kind of grew organically over the years as, as we did this data center move and figured out that we needed this unattended sledgehammer. So even without any planning, we managed to meet most of these requirements that we had set out for ourselves. And about 6 months ago, I decided, all right, I'm going to start working on these last two. And that's when we started running into the problems that come from when you have a software development project that nobody thought of as a software development project and nobody did any planning for. So I started looking at the code and realized that the code was a tangled mess, kind of like this, except way less adorable. Code, not cute at all. It was largely very unmaintained and unmaintainable. Because there was no planning that went into it, it was hard to figure out where to add new features or where to find existing ones. A lot of duplicated code, people just copying and pasting code left and right. Because Unattended Sledgehammer was built in a day, it was mostly just copied and pasted from other stuff and then had some modifications thrown in. It was pretty hard to read because we had this focus on getting the code out the door as soon as possible, in the middle of a data center move. There wasn't a lot of focus on code reviews or anything like that, and we had people who had never written Ruby before. This project's in Ruby. We had people who only had Bash experience or Perl experience trying to write Ruby all of a sudden really quick to get something shipped. And that didn't necessarily lead to the highest quality Ruby code. And we also had a bunch of human single points of failure. So with only a couple people who had worked on this, Unattended Sledgehammer was written essentially by one person. There were only a couple people who could really develop or troubleshoot this code at all. It was absolutely, entirely untested. I know, I'm not proud of it. This is not to disparage any of the past work that my coworkers had done or that I had done. We wrote this code really fast because we had to get it done, and it worked for what we needed it to do. But maybe planning's a good thing. So because my team thought of themselves as ops people and not developers, they thought that tests were not a thing that, ops people don't write tests. So that just wasn't something that we had really considered. There was no deploy process. I kind of went over how many different bits and pieces of this tool suite there are. They all kind of have to interact together. The payload depends on the API, depends on the shared libraries. And if any one piece of those doesn't get deployed at the same time, stuff's going to break. The code wasn't actually testable in a lot of ways. We would have, instead of methods, we'd have just one file that had 600 lines of code. And we were like, yeah, that's fine. Let's just go with it. And because there was no way of testing anything, we had kind of this, pardon my language, fuck it, we'll do it live, push it to production and see what breaks, and that's how we got the code out the door. I should point out that this is pretty important code. This is our infrastructure provisioning code, so we cannot bring up new servers. We can't provision new servers if these tools are broken. The data center team can't really do their jobs if these tools are broken. And as a general rule, as an ops person, I believe that important code, important infrastructure should be tested and monitored, and ours was really not either of those. So I thought, OK, let's add some dev to this. I thought to myself, I have a computer science degree. I can dust that off. And I'm going to refactor this code. And I'm going to write some unit tests. It's going to be great. Except if you've ever used computers before, you understand that yaks come along at the most inopportune moments, and they're like, hey, you need to shave me before you can actually do anything, get any work done. So these yaks came along, and they were like, no. The problem was that we couldn't refactor the code without changing the code, obviously. But because there was absolutely no way to test anything, we couldn't change the code without being utterly terrified that we were going to break things. And more often than not, we would break things unintentionally. So the first thing that we had to do was stop testing in production. I mentioned that we have these kind of two groups of users, the engineers in the office and the data center team in the data center. And technically, we could test the command line tools that people in the office used by running them, which did happen on occasion, more than 0 times. But we had no way of testing this unattended mode. And because the data center team was in the data center, they weren't on email all the time like everyone in the office was. They weren't on IRC all the time. They had much less communication and visibility into what was going on with these tools. So the first thing was to figure out, OK, how can we actually test this unattended mode? So I'm going to start going into some, I guess, code-ish samples here. The principle of the thing is kind of, OK, so we take these existing features that we had, and one of this was what we call a node-specific configuration. So when an engineer in the office runs one of the command line tools to provision a server, it generates this little YAML file that is NFS mounted, so all the machines in the data center that are getting built can access their config files. And it has things like a host name and an IP address. Pretty simple thing. The way that the payload worked to run in unattended mode or not, the payload could run in either mode. The way that it figured out if it was unattended was it checked for the presence of a node-specific config. Because if there was one, it meant that somebody in the office was trying to provision this particular box, which meant that it was not unattended because a human being was attending to provisioning it. So if there was no node-specific config, great, it's in unattended mode. The problem with this was that if I wanted to, say, run this command and test unattended mode, running the command generated this config file, which made it not unattended anymore. So I decided to add another check in the payload that would just check for a new line in this YAML file and say, OK, does this unattended value exist in the YAML file? If so, make it in unattended mode as well. So now there's 2 different ways that we can set this unattended variable in the payload to true and force the code to run in unattended mode. Another thing that I did here, we have this unattended run recipient. By default, the entire data center team has a mailing list. They get emailed when a box finishes with this unattended run. So whether it was successful or whether it failed, they get an email explaining what happened, what's the status of this box now. And in order to avoid spamming them with that, I had the code set up so that if I, for example, ran the code and forced it into unattended mode, it would just email me instead of spamming them. So the way that I would run this command to now test unattended mode is just add unattended at the end as a flag. So Sledgehammer is the tool that has this unattended mode. So I give it the host name of the box that I'm testing the provisioning for. And now I tell it to run in unattended mode. And this just adds unattended true and adds myself as the unattended run recipient to this node-specific configuration. So pretty simple thing, just adding some variables. Variables are nice. And now all of a sudden, we can actually test this code that half of our customers, half of our users are using. The next thing that we wanted to do was to add some versioning to the payload. So the payload is the key part of running in unattended mode. If it breaks, unattended mode doesn't work. Now, the problem here is that for the first 3.5 years of the existence of this tool set, the script that built the payload was hard-coded to always build RPM version 0.1, just every single time. And you can guess the problem with this is when you're always building 0.1, if you build a new version, it overwrites the old version, and you may or may not have overwritten the old working version with a new broken version, and then people get sad. So we can fix this pretty easily. We can use one of these newfangled variables that I've heard about and pass in whatever version we want to build. So that was pretty simple. You just pass this version, literally any other version but 0.1, into the build script, and it will build an RPM of that version. And then when I'm running my sledgehammer command to test this, I put it in unattended mode, and I give it this new version, and it runs and installs that version of the payload. So now I can test new versions without overwriting the production one. And again, it does this by just putting this variable in the node-specific configuration that the payload loads. So then when we install the payload, at this point, the payload in production was still hard-coded to be 0.1, but at least now we have the possibility of testing a different version. I wanted then to do the same thing with this bootable image, the executor that we have. Because we had the same sort of problem. If that you only have one and you overwrite it, you've blown away possibly the only good version that you have. So this feels a bit hacky, the way that we did it, but you will notice that there is a comment in this code. We are now commenting our code when things are a bit hacky to explain what's going on so that future us are less confused. So that's progress. The way that we did this was we decided if a version was passed in, so it was not 0.1, that meant somebody was trying to test a new version, and we built an image called sledgehammer test. Otherwise, by default, it would build the production just sledgehammer version. And this build script, at the end of it, it spits out a command that you can copy and paste, which gets the new image that you've created into Cobbler, which does network booting from various images. You can put like a just default Linux image in there, or you can put one of your own that you've created. And so it's, again, using the magic of variables, spits out the proper command to put either sledgehammer or sledgehammer test into Cobbler. We left the default alone. So by default, it still boots to this sledgehammer image. But during the boot process, you can arrow down, and use sledgehammer test if you want to. So that was pretty cool. A little bit hacky, but again, we now have ways of testing things that we didn't have before. And finally, we figured, OK, we can test the payload, we can test the image. We should be able to test the API as well. So in the payload, when it makes API calls, it has this value that it gets from a global configuration file for what is the URL, what is the URL of the endpoint that it should be using. And so we just gave it a new option in this node-specific configuration to say, if a non-global version of this URL has been passed in, use that one, otherwise use the default. So we use rackup to have people run their own versions of the API, just specify a port, and then the sledgehammer command, which keeps growing as we add new testing capabilities to it, unattended mode, the payload version, and now specifying a local port, which again just puts something else in the node-specific configuration that we use for testing. So several yaks later, we can finally actually make changes to this operational tooling without being just completely terrified that we're going to break things for the data center team, and even worse, not even know about it. So we are testing the code paths that our customers are actually using. We have things that are all of a sudden using variables in different versions instead of just hard coding everything to be production all of the time. We have code that can now load the library files and log locally to where it's being run instead of, again, being hard-coded to production. And we did this all by taking advantage of this existing feature that we had, these node-specific configuration files, and we just expanded those to give ourselves some more options here. So the next biggest pain point that I mentioned was the deploy process. So we decided, we're Etsy, we use Deploynator for everything. We use it for the website, we use it for our Nagios checks. We deploy Deploynator with Deploynator. So we said, why not take advantage of all that and put Indigo in Deploynator? I mentioned that there's all these little pieces that have to be deployed together in sync. The biggest thing that we ran into before was the payload, which had to be rebuilt using this build script to generate the new RPM. That just wouldn't happen And so it would either break immediately or break down the line when somebody else rebuilt the payload for some other reason, and then bugs that had been in the code but just hadn't been deployed because nobody rebuilt the RPM would just show up. So we said, OK, we can fix this by making computers remember stuff for us instead of us remembering to rebuild the payload. So this is a pretty typical deployinator stack. And it runs unit tests. It's got a little widget there that changes colors based on the latest build status in Jenkins. I'll go into the unit tests that we have in a bit. It builds the payload. Using the version option that I added to the build script previously, it now uses a git hash of the latest commit that's being deployed so that we always are building and deploying a unique version of this payload RPM, which means that we now have the option to roll back instead of just overwriting what we had before. And there's also deploy logs, which is pretty nice. The final thing that we did with Deployinator was we added this release notes feature. So what Deployinator would do is it would go through all of the Git logs that were being deployed, and it would format them up. It would add links to the diffs, and it emailed this to the mailing list that include everyone who used Indigo, mostly the data center team. So now, instead of them being in the dark and wondering what changed, did something change, like maybe this is me, they would now know, OK, so here's what was changed, here's when it was changed, when this deploy went out, and here's who to talk to if we start noticing problems. So all of a sudden, they have visibility into the changes that we in the office are making to the tools that they use. So after all of that, we decided that we could finally now, we were in a position where we could start doing unit tests and doing some of the refactoring that we were wanting to do in the first place. And we wanted to think about why we were doing this. Because we're ops people, we don't write tests, so what are we actually trying to accomplish here? We wanted to start making use of inheritance instead of copying and pasting code all over. We wanted to have code that was testable, so being able to mock and stub out dependencies so we could test discrete units of functionality in this code. We wanted to use the tests as some additional documentation so we know what all of these methods are trying to do. This is how I found a method that was called get something that, of course, set two other things, completely unrelated. That was fun. We're giving people more confidence when they're making changes as they're developing on these ops tools. And seriously, we're done with this copying and pasting code all over. That's just not good. So this is a real-life example that I'm going to go through really quickly. This is based on a presentation that I gave internally to the ops team to kind of give them an intro to unit tests and unit tests with the Indigo tool suite specifically. So I'm sure all of you know what unit tests are. This isn't going to be the end-all, be-all guide to how to do unit testing. But this is how we tried to introduce unit testing to this code that had been built up organically over 4 years. We didn't want to completely rewrite it from scratch. I mean, we briefly considered that, but decided against it because that really wasn't practical. But how do we then take this messy, intertwined ball of yucky spaghetti copy-paste code and turn it into something that's a little bit testable? So this is a method that we have that is part of the out-of-band management provisioning. The details aren't super important. The arrows that I have here are pointing to other objects, other methods that are getting called. So we have a whole bunch of different helper classes, which I know is not a super descriptive name, but historical reasons, it is what it is. And the helpers tend to call each other. So this method is in what we call the IPMI helper, because it has a whole bunch of methods that do IPMI stuff. And because of how intertwined all of these different infrastructure provisioning pieces are, the IPMI helper calls the asset management helper, and it calls the SNMP helper. So if we want to test just the functionality in this one method, the logic of the IPMI helper, we don't really want to be testing these other helpers and their functions because those functions have their own unit tests. We also, the asset management, we use a system called rack tables. We don't want to depend, we don't want this test of this logic in this one function to depend on there being a particular server in rack tables. So we're like, okay, how do we take these real helper objects that are currently in the code and turn them into fake ones? So basically what we just did is we added these optional parameters to this method. So by default, it will use the same, I guess, production real-life helpers for the SNMP helper and the asset management helper that it did before. But we now have the option of passing in our own versions of these, which means that what we can do with these, hooray, now we can pass in these optional fake objects, is we can stub them out. This is an example using Mocha, because we're doing Ruby, and Mocha was good enough for what we needed it to do, but I think it's applicable to probably most unit testing frameworks, is we now create our own versions of these objects. We stub out the methods that are going to be called. And so then when we run a test against this find switch port method, we are testing just the logic in that method and not all of these other helpers, these other methods as well. So in this example, the get MAC returns some fake MAC address. That's obviously not a real MAC address. That no server has that MAC address. We're just making it up. And we have other unit tests with the same thing where we say what happened if the get MAC method returns nil. So now we're taking this code that was fairly intertwined, and we're starting to break it apart a little bit so that we can test these methods more discreetly. So tests, that's a good thing. Again, this isn't like the end-all, be-all of unit testing. There's far more to unit testing that I covered in this internal presentation, and way more than I could ever cover here. But basically, our goal here was to start splitting up these methods and start isolating their dependencies so we could start testing the logic and figuring out what these methods were supposed to do. And this was important because, again, this code had grown so organically over 3 or 4 years that without any planning, methods started to turn when they did exist, and it wasn't just a 500-line file. They would turn from something that did one thing to something that did 5 things, and you weren't even sure what was going on. So now we're starting to reason about what's going on, how should we be splitting up this code, how should we be organizing it. So the results, what did we learn from this? What did we actually accomplish with all of this yak shaving? I think first and foremost, the people who are using these tools, this Indigo tool set, are actually a lot happier because we are no longer breaking things for them left and right. We can actually test the code that they are using, and they're a lot happier because we're not, cutting into their ability to do their jobs day in and day out. So they're happier because things are breaking less, but we also made it easier for them to report bugs to us. So when unattended Sledgehammer fails, it drops the box that is being provisioned into a shell. And from there, the data center team can do things like reboot the box or rerun the unattended Sledgehammer. And if they ran into issues before, what they would do is they would pull out their cell phones, take a picture of the monitor that they had plugged in, email somebody that picture, usually just me, human single point of failure, that's not great. And so this was a really kind of unpleasant process for them and for us. So one thing that I did was I wrote this little command line tool called Sledge Helper that is now bundled in with the payload, and what it does is it asks them the questions that I would ask if I were troubleshooting this. So it asks, what's their name so I know who to talk to? Is it a brand new build or a server that we're rebuilding? Because we see different patterns come up there. Asks them the priority. Is this some weird one-off that isn't really getting in the way, or is this, oh God, we can't provision anything, please, please fix this? Lets them enter any additional comments. So in this example, I said this is a new 10 gig host because 10 gig network interfaces tend to behave differently for us than 1 gig. And then what it does is it slurps up all of the logs from the Sledgehammer executor and the Sledgehammer payload, that entire unattended Sledgehammer run, and it takes all this information and it shoves it into a Jira ticket, which has a specific component in Jira, and it gets sent out to everyone on ops who is working on developing Indigo, not just me. So they no longer have to take shitty cell phone pictures to report bugs. They can use the terminal that they're already plugged into and report it that way. We have notably fewer human single points of failure. Namely, I am no longer the only person working on this, so I can do things like come here to New Zealand and talk about this instead of being like, oh God, I'm the only person who can fix this. What if it breaks? So we've got more people writing this code, more people understanding it, and more people helping to test it, which is pretty awesome. And we have testable code now. And actually, we have some unit tests. We have, like, this is the output when you run the tests with Rake. We've got 70 or 80 tests right now. 5 people other than me have written unit tests. We've got tests everywhere. Like, my manager is writing unit tests for some other completely unrelated stuff that he's doing. He's doing some SOX compliance stuff, and he comes over to my desk. He's like, Katherine, I wrote unit tests. Check it out. I'm like, good job. So we've got test coverage. We're not aiming for like 100% code coverage in our tests, but we want to know that the code is in some way tested and that we're understanding what it's doing, just to give us, again, some more confidence in what we're doing when we're making changes. We're not necessarily going to start doing test-driven development, but we are committing to considering testing throughout the development process of these tools. So instead of, if we're going to roll out a new feature, some change to Unattended Sledgehammer perhaps, we're going to be like, OK, how are we going to test this? How are we going to make sure that we're not going to be blindly breaking things? So now we can finally get around to working on the self-service and the bulk build parts of this, which is what, if you remember, we were originally trying to do in the first place. And it took us 6 months to get to the point where we could work on these features, because without any sort of planning, without any sort of software development practices, this project that maybe did start out as just a collection of ops scripts turned into kind of an unmaintainable mess. And so we had these years of technical debt that we had built for ourselves that we then had to undo. So takeaways that I think are kind of more generally applicable to other people's projects. First thing we learned is it turns out you can teach an old ops new tricks. Not all of us are like gray neckbeards who refuse to use any of this newfangled like cloud technology or any of that. People are writing tests for us now, and they're enjoying it. They're seeing the benefit of it. But we're not just testing for the sake of writing unit tests. We're testing because we had these issues, because we kept breaking things for our customers, for the data center team, and we wanted to make sure that we weren't doing that to them anymore. So we learned that we had to start with the biggest pain points first. While I was kind of tempted to say, I really want to refactor this code and clean it up because it's so messy, I realized that being able to test unattended mode and being able to deploy this in any sort of sensible way were more important to the people who are actually using this code. Because really, that's the point. I don't write software just for the fun of it. I'm writing software to solve problems for people. And really, ops code is still code, whether it's one script or an entire project like this. In ops, we say we hate special snowflake servers that were unique and handcrafted, and nobody can reboot them because they might break. So we shouldn't be writing these special snowflake scripts that don't have tests, that aren't in source control, anything like that. So I think it's really important to remember that the knowledge sharing and sharing of responsibility in DevOps needs to go both ways. We should be taking advantage of other people's skills and not shunning them because that's not my job. I'm not a dev. I don't write tests. I think we need to kind of do away with this mentality where we split up what we're doing so much by labels and job titles. So if we, as ops, are going to say to devs, have this pager, be on call, then I think we can be nice enough to say, hey, devs, we're going to write some tests for our code. Because we can solve all these problems better if we solve them together. And with our ops dev powers combined, we can shave twice as many yaks. Thank you.